guys, welcome back. So what we're looking at today is 5.6, justification and proof. So we're going to get into some more proofs, learn about justifications and things, and yeah, let's go ahead and jump right in. All right, so for this first part, recalling features of the rigid motion transformations. So when I use line segments to connect the corresponding points of a pre-image and the image in translation, the line segments are, remember they are always congruent, and they're always parallel. Because every point is translated the same distance and direction. All right, number 2, when I use line segments to connect the corresponding points of a pre-image and the image in a reflection, the line of reflection is the perpendicular bisector of the segments because corresponding points are equidistant from the line of reflection. All right. And number 3, in a rotation, the corresponding points of the pre-image and the image are the same distance from the center of rotation because they move along concentric circles. So concentric circles are just a circle inside of a circle. They all share a common center, but have different length radii. All right, you guys will figure out number 4. I'm pretty sure you can. We've talked a lot about that in the past. The next section, solving for missing angles. Use what you know about vertical angles, exterior angles, and the angles formed by parallel lines and transversals to find the value of x in each of the diagrams. So we're going to do number 6. Remember, when we have the angle on the outside of a triangle, that exterior angle, the exterior angle equals the sum of the two remote interiors. So x plus 87 equals 135. We'll subtract 87 and we get 48. So x equals 48 degrees is our solution. All right, number 8. So here we have parallel lines being cut by a transversal, and these are alternate exterior because they're on the outside of those parallel lines. And remember, they are congruent, which means we're going to take and set 75 equal to 2x plus 7. So we subtract 7 from both sides. 75 minus 7 is going to give us 68 equals 2x, divide by 2. So x equals 34. And that's our solution. Now, the next section we're looking at here is proving. So you have 2 proofs on this. I'm going to do 2-column proof. I'm going to do one of them entirely with you and give you a few tips for the other one, okay? So we're going to look at number 10. So we've got our statements and we have our reasons. What's always the very first reason we have in a proof? Given. And what is given to us? Angle R is congruent to angle U. So angle R is congruent to angle U. What else is given to us? ST is congruent to VT, also because it's given. ST and VT are congruent, then we need to make the tick marks. That helps us see. Now, here's the part where we need to figure out what we have here, what we can visibly see, what we can tell and notice. So here, if we're looking at these, hopefully you're noticing that we have vertical angles going on in here. So we've got this angle and this angle right here, vertical angles. And what do we know about vertical angles? We know that they have to be the same. Now, at this point, we don't have a way to prove, oh, yeah, we do. We have angle, angle, side. So we can use angle, angle, side. Now, there are other ways to take and do this. Another way would be to show that RS and VU are parallel, and then we can use alternate angles, or alternate interior angles are congruent, then they have to be parallel, and then we can show the vertical angles and do it a little differently. But the vertical angles are RTS, so 3, angle RTS is congruent to angle UTV, vertical angles. And then 4, now when we're proving that triangles are congruent, we have to be able to show that 3 parts between them are congruent. So we know this angle, and this side. We know angle, angle, side. So we're to our proof statement. So triangle SRT is congruent to triangle VUT by angle, angle, side. Now, the interesting thing with proofs is there's not necessarily one set way to do them. You can do things differently. Like I said, there was another way that we could have done this one. It just depends on how you choose to solve them sometimes. Not always, because sometimes there's only so much that you can do with any amount of given information. So on the previous one, make sure you start with statements and reasons. Remember, this right here is going to go right here, and your reason will be given. Now, one thing I'm going to help you with is y is the midpoint of v, z, and x, w. So that means this point y right here is exactly in the middle of each of those sides, which means this right here and this right here have to be the same length, and right here and right here are also the same length. So using that given, you can state these things here. So that'll be the next 2 parts of your proof. And then remember, your last statement, just like in mine, is going to be the proof statement. And it'll be either side, 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 angle, angle, side, or angle, side, angle for your reasoning there, okay? And it is a 5-step proof. You could make it 4, depending on if you combine 2 things together. All right, the last section, the go. But like I said, with those proofs, be very, very careful on them. And proof is your key word for this lesson, proof. So on this last section, we're connecting a piecewise defined equation with corresponding absolute value equation. So the graph of an absolute value function is given. Write the equation using absolute value notation, then write the equation as a piecewise defined function. So we are going to look at number 18. So first and foremost, part A, we're writing it using absolute value notation. So f of x equals the absolute value of x. Now, remember, if this were at the origin, we'd just say absolute value of x. But it's shifted over to the left 5 because the vertex is over here at -5. So we're going to put +5 because it's always the opposite sign. And then it's also shifted down to -4. So there's our absolute value notation. Now for the piecewise, now remember, this is the part where we have positive side and the negative side. And we have to say for where each exists. So this top one, the positive side, that's this side of the equation, it's going to be from x is greater than or equal to -5. And then the second one, the negative one, that's this side of the equation. So that's when x is less than or equal to, not equal to, less than -5. So there are our equations. Same idea for all the rest of them. Really look for what your vertex is. That will help you in solving these. That gives you your interval, that gives you the numbers within the equation. It gives you everything. All right, if you guys have any questions, feel free to ask. Have a wonderful day.